Hello everyone, and welcome to WIBU-SYSTEMS' new webinar, Demystifying Industrial Security. Each month, join us for new powerful messages, technical tips, and success stories that will leave you inspired and ready to get your protection, licensing, and security techniques another step closer to perfection. Our hosts today are Oliver Vincent-Reid, CEO and co-founder of WIBU-SYSTEMS, and Hubertus Grobel, head of the WIBU-Security at Swissbit. With a degree in electrical engineering from the University in Karlsruhe and Marcellus Buchheit at his side, Oliver Vincent-Reid founded WIBU-SYSTEMS in 1989 and remains the company's CEO. His passion for software protection has resulted in numerous patents covering areas from secure license management and anti-tampering solutions to dongle feature innovations. He is also serving as chairman of the Protecting Working Group of VDMA. He's a member of the board of directors at Bitkom and the research center FCI at the Karlsruhe Institute of Technology, and is active in the Industrial Internet Consortium. In his 20-year career, Hubertus Grobel has covered multiple positions and roles in software engineering, requirements management and engineering, and security and system design. For the last 2 years, he has been heading the business unit security of Swissbit, which is responsible for combining security and storage technology for the entire product line. Today, we are going to talk about a pivotal change in industrial history, as the advent of connected systems has made security by design an absolute necessity. The careful selection of the components involved is equally paramount. Let's discover the characteristics of reliable and fail-safe embedded memory. This session is being recorded, and a link to the replay will be posted directly to you in a couple of days. You are all muted, but you can post your questions in the live chat room. We will answer as many as we can at the end of the presentation. And now, let's get started.
Yeah, welcome from my side. I'm Oliver Vincent-Reid from WIBU-SYSTEMS. Daniela, thank you very much for your introduction. Welcome everybody, welcome Hubertus.
Hello, welcome also from my side.
So let's talk the next hour about industrial security and what security, code meta security integrated in industrial flash memory can give you as additional benefits. So let me first start with some changes that we are seeing in the connected world, and you see that yourself every day. More and more devices are getting connected. That's your smartphone, your tablet, your compute, your mobile computer, your desktop computer, that are all connected to the internet. But it's more and more intelligent devices, so this IoT, Internet of Things devices in your smart home, in other areas, in a hospital, everywhere, that are connected to the network and in many cases connected to the internet as well. That's in the factory automation and in connected industry as well. So while this connectivity brings a lot of advantages in using and a lot of new features, it also gives some risks, and we will see how to face them. So let's compare a little bit what's in IoT and what's in devices today and in the past, and how it looks like tomorrow. So today, in many cases, we have standalone devices like an infusion pump in a medical system or something like that. It's a device. It has a set of functions and features which is fixed. It's sold from the manufacturer to the user in a one-time business. So normally the product is sold once, there might be some upgrades, and the only regular income is service or consumables and spare parts. And most of these devices, machines, contain an individual hardware that is specially designed for that purpose and has exactly the functions that are required. So tomorrow, from now on, that will change. Devices are being more and more connected. They are able to upgrade the features. So similar like on your smartphone, where you have several apps and where you download new apps for applications you didn't think about when you bought the smartphone. That will be the same with any kind of, with many devices in the future. So, and together with that upgradable features for the vendors, for the manufacturers of these devices, they can create recurring revenues, they can have pay-per-use models, and so on. They can implement new business models. They can sell their products faster because they sell a universal device from the hardware side with the basic functions, the main functions of the device, can bring that to the market in a shorter time, and so get back experiences and user experiences. These devices and machines in the future are more and more using standard platforms on the hardware side and on the software side instead of individual hardware. And with this increasing connectivity, with the option to upgrade things in the field after sales, safety issues, privacy issues, security issues, and so on are coming up, IP protection against counterfeiting, more than in the past with a device that is specifically made for one specific functions. Let me just explain quickly the difference between safety and security. In English that's more clear than in German, but safety means the protection of the environment and the protection of humans against risks that come from a technical system, and this technical system is known, while security is the opposite way. It's protection of a technical system against attacks from the outside that might come from the environment or from humans or from any other external unknown causes. Security threats are seen every day today in the press. It's security threats through manipulation, through tampering of devices, tampering of software, tampering of machines. There's espionage from industry to industry, from secret services, from organized crime. And there are cyber attacks, these viruses like Stuxnet, Duchu or Flame, which cause problems every day in different systems. That's one challenge. The other challenge is the counterfeiting, the piracy problem. And I've on this slide some figures from a study from the German Engineering Federation that shows that only in Germany there are losses, piracy losses from close to 8 billion euro in 1 year, and that most of the companies are affected, and the main source for creating counterfeit products is reverse engineering, so disassembling, dismantling the machines and copying the mechanical parts, copying the software, and more features are realized in software, so the protection of that is becoming more and more important. In Japan, the losses are even higher. If you are looking on PC-based software, the figures are really huge. But we should not be afraid of that. We should see the new chances of this increasing connectivity and see the opportunities that we can do protection against all these things. So we can protect against IP theft, we can protect against hacking and tampering with security systems, and we will see that during this webinar how it looks like in practice. And with flexible licensing, we can realize new business models. And so we have a lot of chances and opportunities we can solve with security systems. So, and why now having a security system like CodeMeter integrated in a flash memory, or having both together in one device? Yeah, first of all, the advantage is having it in one small device. And you see some pictures here on this slide from a USB stick, a micro SD, CF card that contain security and memory in one device. The other advantage of such a combined device is that you can upgrade existing systems in the field, because you already have this interface. You are using this interface for memory so far, so why not updating it with a flash memory that contains security as well? So it reduces the cost, it reduces the space, the power, it offers high reliability and quality, and with excellent components and partnerships, these products are perfect to integrate into your solution. And the partners used in our systems is on one side Infineon for the security controller, it's Hyperstone for the flash controller, and it's Swissbit, where we continue now with the presentation with Hubertus. And Swissbit is a specialist for many years in industrial grade memory, and he will explain what it means and how it works in to have a reliable memory. So I will pass to Hubertus at this point of time.
Hello.
So Hubertus, are you ready?
Thank you very much. Let me. Yes, I am. Is it okay? Good. So. Good. Yeah, thanks a lot for the opportunity to talk about flash memory and the combination of security. What I plan to show you today is the considerations for using flash memory technology in the industrial applications. So what needs to be considered here? What is the basic technology below or behind? It's very important to understand the advantages and potential challenges, and as well what product highlights is offered by Swissbit memory components to overcome these issues or to even improve beyond. The feature of Swissbit is also that we are able to add security to a memory component, and I will show what the benefits are in the integration. At first, I would like to spend a few words on Swissbit. So Swissbit is in the market since 2001 and was the same team was before working also at Siemens Semiconductor Business Unit in Switzerland. So give me a second. The team has an experience of approximately 25 years, which is a lot in this young memory business. The R&D sites are in Switzerland, in Germany, and USA, and we are very proud of the German production facility in Berlin with a throughput of above 1 million products per month. The company is privately owned, which is also in this constellation more or less unique. The Swissbit has 4 business units. These are DRAM modules that we know, and we plug them into our PCs and into industrial platforms. Every day we have them in our portfolio. We are able to supply flash products in industrial quality for industrial applications. And we're able to provide also security components in relationship with these flash memory products. So the base product below is the flash memory product type. That is the second business unit, and the third business unit tries to build on this platform and add security use cases. The fourth business unit is the system in package, SIP business, that allows to integrate new chips and new use cases into new form factors that enables customers to have a higher integration. The storage product portfolio of Swissbit is as broad as the market, so we follow our requirements of the customers, and every form factor that is relevant to our customers we support. We have features that are non-functional, like controlled BOM or product change notification process, long-term availability for stability of your business, as well as technical features that I will come back to later. What needs to be considered for using storage solutions in industrial use cases? There is a list of questions that we need to ask or the customer needs to be aware of to be able to answer when it comes to consideration to use storage in industrial applications. So how critical is the application? That means what may happen, is it possible that a life of a human being is endangered because of a storage component or a storage component being plugged into a system? This is relevant for trains, vehicles, or airplanes, for example, but also for power plants. What is the cost of failure? This is more the economic aspect of it. That means how much does it cost to replace or to repair a system that is worth $500,000 by a component that costs, let's say, $50. So there needs to be awareness of the relationship, what the costs are to compensate, or that you lose your business or have penalties to be paid. What type of usage is intended? So mostly reading would be like more memory maps to be read, and you never change them. So, or you have mostly writing. That means your video recording, or you have a mixed usage to write and read in a balanced way. So, which operation storage temperature is also important to understand to choose the right flash quality. The life cycle of the system that the memory component is plugged into needs to be considered, especially for industrial applications. The life cycle easily reach up to 10 years. So the memory quality should be able to survive that life cycle as much as possible. And if not, then the next question will be how long spare parts shall be available. And for this, a product change notification process or long-term availability program is required. And last but not least, what space is available? How many space do I have to integrate that memory component? What density do I need? And in this discussion, during this discussion, we find the responses, and here's a list of the market segments that we are active in and successful in. So it's about industrial computer, industrial automation, transportation, automotive, security, surveillance, medical systems to record patient data and to protect them, aerospace, military, government, this kind of use markets where it's important to have a highly reliable flash memory quality, or communication networks and automotive, where it also comes to pricing requirements, while the quality still needs to be high. We have these responses. But most of all, it's important to understand the flash memory technology below. It boils down to the so-called NAND cell, which is a transistor that has the ability to store persistently information. And this information is stored in the charge trap layer, where electrons can be collected or removed. And while this load needs to be persistent, the charge trap layer has a non-conductive characteristic, so that the electrons or the electrical load remains in there, and based on that, a channel is conductive or not. The basic operation is, before we do anything with the flash cell, we need to erase it. Erase it means we write a logical 1 to it, and this is done in a manner that the bulk, the ground, is connected to 18 volts, and all the electrons that may be inside this yellow charge trap layers will be removed, so that the electron holes remain, and these are then a positive, let's say, a positive load of the charge trap layer. And this is the basic principle. From on that we build the write and the write and the read scenarios. The term here is the threshold voltage that needs to be put on the contacts to get the channel conducting or not. We see this, how this works here. So we have that cell that has this positive load inside, and now we add one electron here in this picture, so a very tiny amount. So we move the logic, we write the logical 1. The negative voltage is depicted in the picture below. So it's that means we are still in the negative side of this threshold voltage, And that can be detected now in the read operation. Here we have the ability to do a measurement of the conductivity of this channel, and it's conducting. So we see a logical 1. When we write a 0, we apply a field that adds electrons to the charge trap layer, and based on that, when we do the same operation to sense if the channel is conducting or not, then we see the channel is not conducting, which is the logical 0. We've talked about the single level cell, so there's only 1 bit in each cell stored, but very popular as well multi-level cell, so we store 2 bits in one cell. That means we do not we define the amount of electrons that shall be in the charge trap layer, so the voltage threshold is varying depending on the information we want to store. So you see there's 3 states besides the 1-1 state, so there's 4, 2 bits meaning, and this is the write. So, and the amount of electrons we can control either by length or counting pulses that we give to the cell. Reading this is happening in that way that we can that we need to test the threshold voltage and find out under which conditions the channel gets conducting. And this is a threshold we need to know, because that defines which of these 4 blue clouds are active. And so the reading requires sequentially application and increasing of this voltage. That means the reading takes a bit longer compared to, or significantly longer than the single level cell read, which is just 1 bit information. The arrangement of the flash cells are in so-called arrays in 2-dimensional ways so far. That means we have word lines and bit lines, and where the crossing points are, there is each the NAND cell. The future will be, as it looks, will be 3-dimensional, and you see also in the if you see the base layer, we see the word lines and the bit lines, but they are additionally on top of these there is another layer, so it could be 3-dimensional, and that's where Intel, Micron, and Toshiba, the big players, are investing into to increase density and improve endurance. Issues are several that we need to consider to keep the quality of the flash storage up. So when we apply a program write to a cell, the program disturb happens. These green cells are the program cells, but the neighbor cells are also stressed because of the potential that is increased, and this stress leads to introduction of also electrons in these cells, and these electrons, as we've heard, do have an influence on the level of information that is stored. So it needs measures to detect that and to check what the real state and the real meaning of the information in the cell is. That's achieved by error correction codes. The read disturb means the pass-through pages, like you see on the right side, you see the 10 volt, 10 volt. So these neighbor pages will also be do have a potential, and they are affected by the sensing voltage. It's much less than the program disturb, but it's prevalent. And if you only read from the cells, you need to care once in a while and detect that bits are flipping. And here the error correction code gives you an early warning, and as soon as you have these errors, you need to do countermeasures to improve data quality again. Endurance is a topic that the tunnel oxide, the blue one below the yellow one, has a limited capability to let the write process be successfully applied. And once in a while, these electrons that have to pass through the tunnel oxide get stuck and are in there, and that means there's a permanent load shift, and that means the voltage thresholds is lifted to a higher level. Once this tunnel oxide is used or worn, then this cell needs to be marked as bad and cannot be reversed. Data retention is an aspect, so you write data to a cell and you trust, or you just think that it's persistent and will never change state. But this is not true. There's diffusion processes happening in the cell, so that electrons like to leave this charged up layer again. So they will dissipate into the substrate, and this means there's a shift towards ground with these levels. Especially at high temperature, this effect is accelerated. So it needs to be taken into account that a kind of refresh or so needs to happen. But in the end, the tunnel oxide has also here limited capabilities and will in the end lead to a used or worn cell, and the bad block management needs to sort this cell out. The aspect of temperature is also very interesting, that depending on the write temperature, or the temperature that is active during writing, has an influence of the storage. The lower the temperature, the more clear defined the states are. The higher the temperature, the more the less distinct the states are. So when reading these information, you don't know when this what the temperature was, so you don't know the exact precision where the levels are. So you need to do retry. So that means you start to find the position and then get the proper decision where which information is in the cell. So you see we have discussed SLC and we have discussed MLC, and you see there's a lot happening in the cell and this management around. There's a lot more management even necessary for TLC, which has a very limited life cycle, and you store 3 bits inside one cell. If you show endurance, retention, and costs in a diagram for this various technologies, then you see a single level cell has a high endurance, has a high retention, unfortunately also high costs. Multi-level cell has a weak endurance, but very excellent data retention and medium costs. So for reading only use cases, this MLC would be considered as perfect. And TLC is for industrial application not an option, because it's not offering the right quality. What do we do to overcome these issues and to improve the features of our cards? So the safety features: when you switch out the card at any state, you won't lose data. This we call power file management. We have redundant firmware, we have error correction codes inside, and we have read-retry, what I explained, that we are able to distinguish between low temperature and high temperature writing. We have endurance features to sort out bad blocks, to early detect candidates for being out of order soon, and this kind of dynamic data refresh happening. This is what we call endurance features, and we have performance features that improve the performance for specific use cases. So some hosts do need specific support and to improve the use case by certain writing or reading operations, as we also offer. And additional features like smart data, you can check in which state the flash memory is. Does it need to be replaced soon? An in-field update is optional. So if there is an epidemic thing happening in your devices and you need to correct it by the card and not by the host, then it's an option to have in-field update for cards. Customizing is also an option where Swissbit is very good at, and more. So basically, we're following the market and the requirements. We have requirements for product-related services, so customized firmware and drivers, customization, logo printing, product change notification process, all this, as well as for when it comes to security and flash memory, customer support, design and support, connection with ecosystem partners, for example, WIBU, when it comes to licensing, and all this we offer beyond flash memory. Now let's talk about the Internet of Things and combining flash memory and security. The Internet of Things comprises of infrastructure like power plants, traffic lights that have so far been standalone, but now they get online, and of course there's benefits, but there's also risks, so it needs to be, there's a complete new attack vectors that need to be considered. Mobile and portable devices like the laptops and mobile phones, that's obvious as part of the Internet of Things. Classic Internet equipment like servers, routers is also obvious, but what is less obvious or coming up to now is vehicles. Cars could be hacked, they are online, and they could be even be interfered by during the driving, which is a really bad impression. And this needs to, once these cars get online, they need to have also security measures to protect against attacks. And production plants and industrial espionage, Industry 4.0, 4.0 needs to be taken into account also for securities. And there's various levels how you can achieve security. Global Platforms says you can do it with only software, so that comes low cost, low protection, or medium, you do low extra cost. You choose, for example, the trusted execution environment inside the processor, but you get also medium protection. Here's also valid, you get what you pay for. Software and tamper-resistant hardware comes with extra cost, of course, but you achieve also highest protection. And this is also where WIBU is active, that you have a secure element in your devices and can protect your assets very efficiently. Let's discuss about the options that you have to achieve your securities. That means you can choose a SIM card, which is a smart card, but binds you to an MNO, mobile network operator. So when you want to change the secure element, you need to change also the contract. You can choose a trust zone, trusted execution environment, but then you're pretty processor specific, and it's also non-replaceable as the processor is soldered in your PCB. You have a TPM option, which is soldered on the PCB, is then bound to a specific board and also not replaceable. Pure software is an option, but we don't discuss this here because this is extremely insecure. So we consider the new approach that we have here is that we combine security and storage in a secure storage device that offers a perfect fit for a lot of use cases. And if it's removable or not, it's a second discussion, but it helps to support maintenance and flexibility and security to improve a lot. That means cost-effective field replacement. As we have seen, the flash memory is subject to usage and has a limited life cycle. So does also security. So it's a very good decision to have the security standalone replaceable. When you choose security, you have the options with this combined secure storage. You have the option to choose the highest common criteria certifications that is available in your devices, while the pin compatibility to your existing field installations or your low-cost sourcing, let's say, of hardware is not affected, because the memory pin compatibility and functional equivalence is granted. The security comes as an extra. And yeah, so you can increase the security on existing installations while staying independent from third parties without any enforced revenue share models. Coming back to this picture, so with the security options in principle, we say it's now possible to provide a component that every embedded system needs. I mean, this is flash memory, it needs it. And we offer an additional secure element inside, which lifts the security of the complete system to a new level and allows to address new markets and opportunities or reach new security levels. How does it look like in a card? We have a memory controller, of course, and we have a flash memory, but inside we can integrate also a secure element that you know from your passport or your SIM card or your corporate badge. These kind of smart cards that we can integrate, and we have the capability to add applications to the flash memory controller that enforce policies, security policies, and ensure the communication and data is secure. Use cases would be with these kind of storage cards, code storage and signing. So you can ensure that your code has not been changed and is still the original one. You can store user data or customer data in a secure way and load it into the cloud. You can have license protection where WIBU is successful in, that you monetize your hardware, you monetize your IP and your software in a secure way. And you can make the device by trusted platform like boot processes very secure. You can have remote access to the device by encryption of telemetry data and data in transit. And you can have true random number generated in a system that is typically not able to provide true random numbers, but the smart card inside such a card is of course able to do. These devices do support a lot of use cases. So, for example, having a secure micro SD card into Chancellor Merkel's telephone, or encrypting emails, protecting the device login also of a PC. You can have a data protection profile implemented in video cameras, be they portable or fixed installed. You can have a secure industrial installation, for example, that you ensure the quality of the components are intact, or you can protect against tampering in industrial installations, or you just do it like in a simple device like a Raspberry Pi, where you can make the smart card as an add-on in combination with a bootable micro SD card, and turn the system, which is a local system, into a very high secure system. So this is what I wanted to show today to you, and I hope you like it.
Yeah, thank you very much, Hubertus, for your presentation. I think that's an excellent overview how flash memory works in principle and what the difficulties and to make really reliable and flash memory solutions that are able to meet industrial requirements. Also, the use cases you presented are very interesting, and it shows that a removable security component has a lot of advantages compared to a soldered, fixed soldered security component to a system. Renewable security is something that is really important, either by being able to upgrade an existing security solution or by exchanging them in a removable device. All right, so let's continue with some working principles of the protection schemes. Then I would continue with solutions that we are offering and processes, and showing some products and use cases of these products that are in place already since several years. First of all, how to protect the IP, the intellectual property, your know-how that is contained in algorithms, in source code, in your products, against reverse engineering and against IP theft. So that is can be done by encryption. So on the flash memory, this data or program code is always stored in an encrypted form, and in this form, reverse engineering is not possible. The second is software and product protection, so against counterfeiting, against creating pirate copies. That's done in the same way because the data and the software is encrypted. It can be copied to another device, but it cannot work. Important is that then for the use in the original product, there is an unclonable cryptographic key storage. So the next part of a requirement for IoT devices, for connected devices, is that I'm able to flexibly configure which functions that are in the device can be really used. And that is also realized by encryption. So different parts of the software realized features are encrypted in a different way associated with a license, specific license. And what's necessary here is that the crypto device, the security device in a product is able to store multiple keys, not only one, so that you can configure which features are possible. And additionally to the keys, it's also necessary that you can store some options, like, for example, that the key can be used until end of October, or it can be used 20 times, or something like that. So having a licensing system like that, and also a way to distribute that, enables new business models and enables you to monetize your software realized functions in your products. And the last point, and that's getting more and more important with connected devices, is tamper protection. So avoiding that somebody from the outside can replace the firmware or can modify the data. And this is done by using asymmetric cryptography. So the data, the parameters, the software is digitally signed, and the device or product can then detect themselves if the code or data is not modified and if it's really coming from somebody who is authorized. So that's a prevention of manipulation, cybersecurity, really important for IoT and connected industry. In industrial application, there are a little bit different applications than, for example, for software, only for software licensing in the office area. In the office area, you can assume that most of your users are really honest and they want to be in compliance with the license agreement they have done with you. So for them, a licensing system helps them to stay honest, and they don't have to take care of themselves that they are not using 200 licenses when they only have an agreement for 180. But in industrial applications where software realized functions are in devices, for example, in critical infrastructures for power, for logistics, the attackers are not the users of the systems, but the attackers are really organized crime. It's terrorism. In case of product piracy, counterfeiting, it's the competition. So for that, you need really a high level of security. And that means that software-only based solutions in most cases are not secure enough, so you need the use of secure elements. And these secure elements like smart card chips, these security controllers, they must fit the industrial environment, so extended temperatures. They must be built in devices with industrial interfaces. That's different from the use in your credit card or in your passport. Then the further requirement in industrial application is that you flexible can store multiple licenses, even from different stakeholders and rights owners. You need to store certificates, maybe for communication security, for example, certificates in OPC unified architecture. And requirement is that not all industrial applications, all systems can be exchanged completely. So being able to retrofit devices that are already in the field is a big advantage. And if we have the security device in a memory card, where today a normal memory card is used, then there's really an option to upgrade existing systems in the field with security. So let me show what are we at WIBU-SYSTEMS offering. So the heart of our technology is really how to store the keys in a secure way associate license options with the keys, and then do the crypto operations like decryption, encryption, symmetric, asymmetric, random number generation, and so on. And that's in all our protection devices, doesn't matter which interface. And the same features are also available in software-based solutions, offering a low to medium protection level for desktop, for some applications also enough. So that's the heart of our technology, and you see that on the slide as well. The next part is the tools, because just having only an API to do some symmetric or asymmetric encryption doesn't help you really to make your system secure. So to be able to do that, you really need tools to realize, to protect your software and convert it from an unprotected to a protected one, to do applications like secure boot, signature checking against the certificate chain, storing certificates for OPC-UA, and so on. And that is all included in the protection suite available for different development environments and operating systems. And last but not least, back office integration is also important. So what do I talk about? So if you have a product and that is be sold in 3 different versions with basic software, with some additional features, software realized, then you can do the production for all products in the same way, and then in your SAP system, in your ERP system, you have the software-based, software-realized features associated with a part number as well, and automatically in your production with the bill of material for your product, the licenses and keys are created and distributed to the product on the production side or even after sales. But that's important. This back office integration is important to integrate that licensing and security things in your business processes. So, and that's how it looks like. So one time you have to do the integration. You have to do the integration into the software. On the left side, the unprotected one. Using our protection suite, you get the protected one. And you integrate one time this license creation and deployment into your business process, so you can connect your CRM system like Salesforce, you can connect your SAP ERP system, you can connect an e-commerce platform, for example, for after-sales things like in an app store. You can connect a license portal so that your customers can get their licenses, move their licenses themselves using your online service, and you can also get the license from your software directly. So that's integration into your process. That needs to be done once. And then later, after installing that, you can deliver your products to as many users as possible, individual for each, in a fully automated way. Now let's come to the combined products with flash and security. Here on the picture you see some of them, a micro SD card, a SD card, CFast card, a USB token, and all of them, common for all of them is that they contain a certified crypto controller, certified crypto libraries, the market-proven CodeMeter firmware with all the functionality for licensing. They are available for extended temperature. They are combined with high-quality, high-reliable flash memory, with industrial flash controller from Hyperstone, and with all the qualification for the flash memory part and the production in the Swissbit factory in Berlin. Of course, they have a fixed bill of material, product change node service, and the products are available on a long-term base. What applications are really possible if you combine the secure element, the security, and the flash memory in one device? You can do mobile applications where you have the software that is running a device on this USB stick or on this memory card. You can also use the memory component for delivery of data that might be databases, service documents, maps. You can store some kind of logging data like a flight recorder in a secure way. You can use it for secure boot. You can, as these interfaces are very common in use, you can update existing systems in the field. And we can also offer the CM sticks and the CM cards customized for you. Customized means they have special laser engraving, they might have a special case, they have an OEM label and package, and we can also, prior to shipment, do some data duplication and storage of keys or certificates on the device already. So these are a lot of options. So let me explain the CM stick M for the USB interface a little bit more. On USB side, we can have on one device multiple partitions, so you can create something like a CD-ROM partition. If you connect it to a system, the system thinks that's a CD-ROM, and what it means is that the data on that is read-only and can have an auto-start function as well, so the customer cannot unintentionally delete or modify some contents on the CD-ROM, while you as a manufacturer have the option to even update the contents of the CD-ROM partition in the field. The public partition is clear, that's just a read-write partition. You can have it, you can disable it as well. You can have a private partition which is encrypted and accessed only using the smart card chip and the security functions. And the so-called secure partition. Secure means that this partition is never being seen by the host, by the operating system, and it can only be read or written by the CodeMeter API. The CM stick M is available in two different configurations, two different options. One is the industrial version that comes optionally with -40 to +85 degrees, and it contains SLC flash memory. In fact, there's a micro SD card from Swissbit integrated in that USB device, and that's offered for capacities up to 8 gigabytes today. And we have a commercial version that contains 2-bit eMMC flash memory, MLC memory that stores 2-bit. Hubertus explained that very well before. And that is available for higher capacities and offers a very cost-effective solution where this very high requirements on the flash memory are not available, so a very cost-effective solution. If you are comparing now having a secure element separately and a memory component separately, that's possible. That's the blue line and the orange line, the first two. The blue line is having industrial flash, like a high-quality product from Swissbit, and a CodeMeter security component without flash memory from us. Of course, then you need two components. You need more space. You have probably more cost, and you don't have these functions where the security controller directly influences the flash memory. Then the second one with using retail flash, of course, if you're looking on component cost, this one has the maximum points, it's the cheapest, but the quality of that industry qualification is 0. You need more space and so on. So from that point, it's not that good. If you are looking on the CM cards like the micro SD card, CF, CFast card, or SD card, that's a red line. There you see you can reach you have fully industrial qualification. You have the least possible space that you need. It's upgradable in the field. So existing systems that are using a normal SD card today can be upgraded with a SD card with security. The power consumption is very good. The security and the security options are perfect. So you see here that this offers a very good relationship. There's a white paper available on our website that explains how we get these ratings for the different topics for these different components. So that's always important to see that really the total cost of ownership is the perfect using such a combined device. Let me show you, coming to the end, some real applications where the combination of industrial flash and security in one device is used. So one of the applications you might use yourself every day, or not every day, but from time to time. If you pick up some money from an ATM, and that ATM is coming from Winco Nixdorf, that's a German ATM maker, then these systems, the bank staff or service technicians, they are using a so-called crypta stick, and that's a CM stick M, a CodeMeter USB stick with high-quality flash and the smart card chip inside to authenticate against the system, to be able to execute some service applications, and for the service technicians, they also get back some logging data to that special device. So this is something that is integrated in a standardized process and increases the service efficiency for the maker, for the supplier of the ATMs. A second application is mobile forensic software from a customer in US from us. So they have the application mobile on that CM stick M. They can securely store the investigation data on that stick using these multi-partition features, and also can even boot the system in investigation from that USB stick in a very user-friendly way. Other applications are in the medical area. Let me explain only one of these on the pictures. The right one from Sirona, the dental company. It's a machine that is producing ceramic inlays for your teeth while you are at the dentist, so without a provisional filling and so on. And these machines are containing a security and memory device to reduce counterfeiting, so to protect the intellectual property in the machine. One purpose. Second purpose is to enable different functions of the machine that are sold separately. Another option is realizing new business models that the number of ceramic teeth that are produced by the machine are counted, for example, to use some pay-per-use models. And as medical devices usually require a certification from FDA in the US or Medizinproduktegesetz in Germany, with the CodeMeter security, it's made sure that the device is really working and the software and the data is not manipulated as they are approved in their approval process. Other applications are in the gaming area. You see here a game machine from Marox and that you find in many casinos. Here, of course, there are also high requirements, and there's a CM card CF, so a compact flash card, is used to do a boot of the system, a secure boot of the system. So using another card, the system will not boot. It's also used for the IP protection of the game software, and it's used for tamper protection of the configuration data that makes sure that the game machine really collects more money than it gives back, or that the relationship at least cannot be changed by some attackers of the system. So making sure the integrity of the whole game machine. Another getting more and more important application area is industrial automation. In industrial automation, the devices become more and more networked. So tamper protection for the software running on a PLC is getting more and more important. And that is realized in Codesys PLC software, this boot project protection. It also offers the machine supplier to use the CodeMeter API for individual licensing functions, and the source code protection in the development tool is integrated as well. Same is with Bernecker and Reiner, and a last application with Rockwell Automation, one of the largest PLC suppliers in the world, is currently the protection of the source code in the development tool with a very sophisticated rights management system and the deployment of these rights over the internet with a portal in the internet integrated in that Studio 5000 development tool from Rockwell. Some words about WIBU-SYSTEMS at the end. WIBU-SYSTEMS has been founded in 1989, so more than 25 years ago. The headquarters is still in Germany. We are focused on protection, licensing, and security. ISO certified, of course, having subsidiaries in the US, in China, sales offices in several European countries, and distribution partners in even more countries. We are working together in developer programs with companies providing operating systems, because the security always is not, mostly not done, used in systems that are programmed from the first beginning, but the systems are more and more used standard platform, standard operating systems. So good operating system support is something very important. For example, in Wind River, a 100% Intel company, they have integrated the CodeMeter technology in their VxWorks 7 operating system from the scratch, so you always have the chance to use all the security functions easily. We are working in research projects with universities and research institutes. We are active in business organizations, and especially, for example, in Industrial Internet Consortium, OPC Foundation, SD Card Association, these organizations that take care about and working hard making the new applications of the connected world more secure and reliable. Yeah, some of our customers and partners, and you see they are in all areas like standard PCs, like PC tools running in the office, like industrial automation, like medical, like finance and banking, and so on. So let me summarize at the end. What is the advantage of having a CodeMeter secure element, security system, and flash memory in one device? So it perfectly fits because it's for IoT devices, for cyber physical systems, embedded systems, PLCs, because it requires only a low amount of space in your system. It is low power. It's only one component. So at the end, providing you a minimal total cost of ownership. It's highly reliable and available for a long time. It can be used even to upgrade systems that are already existing in the field. It provides IP protection for software and data as well as tempo protection, and it enables you to implement new business models. So that's the goal of this combined system. And here we really combine the competences of different partners. Swissbit with the big experience in industrial reliable memory products, and our long-term experience in that protection and licensing systems. So thank you very much for your participation in our webinar and your interest in our solutions. You can contact us anytime, ask Hubertus from Swissbit and us and tell us your requirements. But now let's see if we have some questions already collected. Daniela, how is it?
Yeah, we have received a few questions here. Let's start with you, Oliver. How difficult is it for device or system developers to integrate CodeMeter security?
Yeah, that's a good question indeed. And it's very important for developers that they can do the implementation in an easy way. So the way I mentioned before that the CodeMeter security is already integrated in VxWorks operating systems from Wind River, that may, and in the development tools associated with that, that makes it much more easier for the developers. And we have development tools from many different operating systems and environments, so that the developer can really do that in an efficient way, not starting with just applying symmetric and asymmetric cryptography and thinking about all that themselves.
If you don't mind, Hubertus, we could continue with you.
Sure.
So we have a question that reads, industrial grade memory is more expensive than memory for the consumer market. What are the qualification steps Swissbit is in charge of?
Okay. First of all, the raw material is more expensive, that's obvious. And handling this material, you need to choose the right one. When you qualify a product, you have to test a lot. So you need to be able to do life cycle predictions. You need to do deep testing and know really when the card is at its end. You need to provide a quality that has a well-defined and stable behavior. That's, I think, most important. And last not least, each component is individually tested according specification of the customer or meeting our quality standards. And each card is really then temperature-wise tested, which is a phenomenal, I think, a great thing that you really know in the temperature range you want to have it. It will be working. So this all is a demanding process and requiring a lot of resources on every level. And yeah, so it has to be more costly, and I think it's worth it.
Thank you, Bertus. So last question for you, Oliver. What are the security requirements of connected industry?
Some of them, I think most of them we have discussed during the webinar already, but let me try to say the most important ones. As soon as you have devices connected to an open network and connected to each other, I think it's very important that all these devices get their own identity in a secure way. So, but that is not enough. So I think all the three topics, protection, licensing, and security, are important. Security is, first of all, the own identity, but security as well is something like secure boot, like tamper protection, really checking the integrity of the system software and the data, one step, and then protection is getting more important because more and more value in connected industry and Industry 4.0 is in the data in the production process, so that data needs to be protected against counterfeiting as well. So the know-how protection, IP protection, and new business models require flexible licensing systems. So all together, I think will push the business cases and push the benefits of connected industry.
Yeah, it seems like there is no additional questions at this stage, but of course everyone is invited to submit their own personal inquiries directly to us at a later stage.
All right, then for me, I would like to thank you for your interest and for participating, and really please feel free to contact Mr. Grobel and me if there are any open questions, or to contact Daniela. You will have all the contact information and you get the link for the recordings as well. So I hope we could provide some interesting new information for you. Thank you very much for joining and have a successful day.
Thanks also from my side for interest and opportunity to talk to you. Thanks, bye.